Musician, mathematician. Something that really tickled me, and I thought this is an ideal time to talk about this topic. It is accepted that mathematics is the foundation of most items out there in life. Be it architecture, be it geography, be it the algebras and the trigonometries and the geometries of this world. But is it accepted that music has a foundation of mathematics? Before we get there, let me ask a few questions. Is a musician a composer? Not necessarily. Is a composer a musician? Most likely. Now there is common ground between musicians and composers, and that is mathematics. Musicians always play composed music, but that doesn't make them composers. But this common ground of mathematics in musicians and composers can actually be substantiated scientifically if you understand the varying elements of music theory. So, in 1987, Reginald Smith Brindle, a composer, you can Google it, and a music professor at the University of Surrey, he wrote, and I quote, "Music theory has no clear foundation in modern mathematics. Yet, the basis of acoustic musical sound can be explained and described mathematically." And he states this, and he bases this statement of his on the fact that music exhibits arrays with number properties. And before we can go further, we need to understand what an array of numbers is. So numbers is a set of numbers, and it becomes an array when they exhibit a specific pattern. And mostly this pattern you would find in rows and columns. Now, arrays of numbers is similar to music theory. They can be described, and when you need to define them, you arrive at the point where you need to where you actually establish that there are various elements that are common to both mathematics and music. And these are form, rhythm, pitch, pulse, and harmony. So before I go further with my speech, it's important to realize that this is all to do with time. So a music piece, when performed, takes place over a specific period of time. It starts at note 1, and as time goes along, and 5 minutes later, for example, then it's the end. And that music piece is then played over this period of time. And bearing that in mind, let's then talk about these elements. Now the first one is form and rhythm. An array is a block of numbers. And similarly, in music, you would find a block of activity in that music piece. And these blocks, in musical terms, can be defined in various ways. For example, a verse. So a verse of a particular song would be a block that contains a number of notes spread over a period of time. And this note, this array of numbers, this array of notes, you would find is repeated in a song 2 or 3 times. So it's the array that you would find at certain intervals in a particular piece of music. You will also find a chorus. And a chorus is also a block. And this block is, it's going to vary from the verse, but it's also an array of numbers or an array of notes. And verses are normally used to alleviate monotony in a music piece. In common today, these blocks you will find in architecture, for example. They are repeated and you would find them in various places. Pitch and toss. So each building block has a number of notes. And these notes are spread over time and then create that specific melody. So, for example, da 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 da. There are the notes of that particular block. They are at varying pitches and they are done at a varying speed, which is the tops, the tempo. Let's talk about the third and fourth item, harmony. Now, harmony has to do with these things working together, and that's where physics, indirectly mathematics, comes in. They need to talk to each other. An example is your wheels of your car. When you're driving your car and they're unbalanced, can't believe it. The wheels shudder, there's a problem. And that's because they aren't in harmony, and that's the physics of music. Similarly, in music, when those notes don't talk and work with each other, it's unharmonious and it's unlistenable. You can't actually experience it. So, gentlemen, having an understanding of this array and how mathematics comes into it, I suspect that you would agree that composers will probably be mathematicians. No? Well, I agree with you, not necessarily. But the successful ones are. Take Brian May of Queen. I mean, this guy's got a PhD in, let me have a look. Where is that? Astrophysics. And Art Garfunkel, of Simon and Garfunkel fame, he's got an honors degree in mathematics. So you still don't agree? Well, each of us as human beings has got a bit of mathematics in us. And as we get older, it isn't really a problem. The problem is that we lose some of our functions. Still not convinced? Well, let me introduce you to someone that I really enjoy. And I know there's some members here that also do. This guy was born in 1770. At the age of 28, he started losing his hearing capability. And he died at the age of 58. The last 15 years of his life, he was totally stone deaf. But that was the period that he wrote his most renowned pieces of music. I'm sure you agree with me now. Being stone deaf and composing a piece of music, not being able to hear what you are doing, you needed to have a mathematical insight. You needed to be a mathematician. And gentlemen, that guy's name is Ludwig van Beethoven, Mr. Toastmaster.